Hello, hello, hello. Please, welcome to all of you. Welcome for this second keynote speaker of the day. So my name is Laurent Ferrara, or Lorraine Ferrara, if you prefer. I'm a board member at the IIF. I'm also organizer of the next ISF that we will have in Paris, or in France at least, next year. Okay, so we have the great chance today to welcome Keith Wiebe. So Keith is a senior research fellow at the International Food Policy Research Institute in DC. Keith is leading a research program on global futures and strategic foresight. And prior to joining the institute, he was deputy director of the Agricultural Development Economics Division of the United Nations Food and Agricultural Organization in Rome. So Keith is really a specialist of the field. His areas of research include, for example, land tenure, natural resources use and conservation, agricultural productivity, and a very hot topic today, which is food security. So Keith, it's really a pleasure to have you, and welcome to the ISF.
Thank you. Thanks very much, Laurent. I think this is working now. Pleasure to be here. Thanks to the organizers also for inviting me. And apologies to all of you if your current food system was interrupted at lunchtime in order to get back here on time to talk about future food systems. That's one of the trade-offs that I'll be talking about. I have to confess it's a little bit daunting to stand in front of a room full of forecasters, because often in our work doing foresight and modeling, one of the things we have to say to our partners and clients is to say, sorry, we can't do that. We're not forecasters, because we don't make predictions. We look farther into the future, and we do lots of conditional things. We're really big on qualifications. If this, then that might happen. But that's part of informing a dialogue process that I'll talk about today. One more word of introduction. As Laurent said, I'm at the International Food Policy Research Institute. It's one of a network of agricultural research institutes around the world. You may have heard or may not have heard of the CGIAR system. It's a really long, clunky name, which is why we don't actually say it very often, but what it originally stood for was Consultative Group on International Agricultural Research. So IFPRI is based in Washington, focuses on food policy. Most of the other centers are based in different developing regions, focusing on a particular commodity, a particular region, or a particular topic area. We work in collaboration with all of them. So I want to acknowledge contributions from lots of colleagues at IFPRI and around the CGIAR in what I'll present today. So I'll talk a little bit first about food systems, why we don't just talk about food or agriculture, the wider context there. A little bit about foresight and hindsight as a way of thinking about the future. How we bring the work that we do to inform decision making, mostly with national government partners, but not only. And finally, a few thoughts on foresight as a process. And I'll get to that towards the end. So food systems, not just production and consumption. For the past 10,000 years, at least, most of our food has come from agriculture, domestication of crops and livestock. Today, there's something on the order of 500 million farms or farm households around the world, most of them in developing countries, most of them relatively small scale, so 5 to 10 acres, as opposed to an average size in the US of in the order of several hundreds to 1,000 acres or more. On one side, so many producers. On the other side of the balance, all of us, 8 billion of us in the world today, are consumers, and that's a really important part of a food system. But in between, there's part that often is overlooked, even though it's bigger than the production side almost everywhere. And that's the whole part of the system that involves supply chains, value chains, transport, processing, storage, marketing, all sorts of things that go from getting food from a field or another source to our table. Going back upstream, of course, critical inputs, land, water, seeds, genetic resources, labor, a variety of technology and so forth. That's part of the food system too. And if you keep on going back even beyond that, what's the enabling environment, the institutions, the research that informs development of new technology, innovation, infrastructure, and so forth that make food systems possible. So we don't look at all of these in the same detail, but it is really important to keep this wider context in mind. Just briefly on the importance of parts of the food system beyond the production side. On the far left, all countries on average, food systems represent about 12% of total GDP, and of that, about 2/3 of that actually occurs off-farm. It's what happens after production is harvested and moves its way through the supply chain to reach us at the consumer's table. The pattern varies a lot across income groups. So in the next category, low-income countries, agri-food systems as a whole represent a much bigger share of the total economy, but the proportions are reversed. Most of that is on-farm production with a smaller share devoted to the rest of the food system. And those numbers change. As a whole, much smaller percentage of the total economy in high-income countries, and there it's mostly off-farm. The production itself is actually only about 1% of the economy. And the same is true of farm labor in the US, about 1%, 2% of the total labor force, as opposed to 30, 40, 50% in low-income countries. I won't go into this much, but just to show some of the different components of the off-farm agri-food system, mostly processing, trade and transport, a little bit on inputs and food services and so forth. But again, some of the patterns vary by income size. Tremendous change in food systems over the last generation, over the last half century and more. Among those, huge increases in production. Food production in aggregate has basically tripled over the past half century, outpacing growth in population. Tremendous increase in variety, what's available in supermarkets today around the year from all over the world. Until recently, over the last century, food prices have been declining on average, with some notable exceptions. But recently, we've experienced pandemic, we've experienced impacts of recent conflict in the Ukraine, and other factors that have made food prices higher in many parts of the world. Similarly, reduction in hunger over the past half century at least. 50, 60 years ago, estimates were about 1 billion people, and that's a much higher percentage of total population at that time were hungry in terms of access to calories, just basic dietary energy. That number went down in recent decades to 900, 800, 700 million. It's ticked back up again in the last couple of years, partly as a result of the pandemic and other recent shocks. Nevertheless, lots of opportunities, lots of challenges as well. The resources that are used in agricultural production and other parts of the food system have depleted and degraded resources in many cases, land and water. Tremendous amounts also lost to food loss and waste. The data here are very poor, very sketchy, but estimates range in the order of 25 to 30% lost either in the post-harvest part of the food system. That tends to be a higher share in developing countries, or wasted, which is generally refers to waste at the consumer level. It gets all the way to our tables, but we don't consume all of it. Hunger, overweight, micronutrient deficiency, these continue to be big challenges. I already mentioned hunger just in terms of basic dietary energy, something like 800 million people in the world today. About 1.5 billion people are estimated not to be able to afford a healthy diet. 2 billion people estimated to be overweight. And these are figures across the world, not just in developing countries. And micronutrient deficiency, not enough vitamin A or zinc or iron or other essential nutrients. Again, affecting probably a couple of billion people. They don't add up. Some of these are conditions that an individual or a household might experience more than one of these. But nevertheless, real problems in different dimensions of demand and consumption side. Population growth, historically a challenge. You probably all know the name Thomas Malthus. About 200 years ago, a little over 200 years ago, he wrote an essay on the principle of population, which in short said that population is inevitably going to grow faster than food production, and therefore we are doomed to a future of famine and misery and so forth, all these things that earned economics the label of the dismal science. Well, that has been a challenge. I'll come back to that in a little bit. On the other hand, population decline can also be a challenge. We heard this morning about the role of population or growth in labor force in terms of economic growth, in terms of supporting an aging population. So in some parts of the world, some parts of developed East Asia, particularly also in parts of Europe and North America, population growth slows, starts to decline, and you have a smaller labor force supporting a larger and aging labor force. So that also brings its challenges. Climate change, I'll talk about that today. Pandemics and conflict, of course, we've all experienced or read about recently. And behavior. Behavior is a challenge simply because we have 500 million producers, 8 billion consumers, all of us making individual choices every single day. Sometimes those choices will be noble, far-thinking, far-sighted. Sometimes they'll be very immediate. Understandably, that's the way we're programmed. That's a challenge to addressing collective challenges like climate change, like poverty and hunger on a global scale. But there are also opportunities, and those have to do, I won't go into detail, but improvements in information, better access to tools that we already have but maybe are not accessible in all parts of the world, innovation, technology, economic growth. Behavior is an opportunity if we can change behavior. Doesn't mean everyone changes everything that we do, but through better information, better understanding, better policies, there are ways to guide individual behavior in ways that may be less detrimental or more favorable to collective good. Just briefly, I won't go into the details on this. At the center you see production, supply chains, consumption, some of the main components I mentioned. Just to indicate, and this is, by the way, this is a kind of figure that one of my colleagues refers to as a horrendogram. There's just arrows going everywhere. The point is to say lots of things are interacting here, and that's what makes it challenging and interesting to look into the future, because we want to try and account for as many of these as possible, whether those drivers are climate or technology or demographics, market conditions, or what have you. So let's look at a couple examples of drivers of change on the demand side. So again, we heard this morning about population as a driver of economic growth. We're also interested in what that means as a source of demand. And Malthus is one who said in particular he expressed a lot of concerns about pressure placed by increasing population and demand for food. Population is growing. Growth rates are slowing though, and particularly in East and Southeast Asia, we're approaching a point where projections are that population will start to decline. In fact, China last year, for the first time in several generations, reported a decline in population. India passed China as the world's most populous country recently. And for that region as a whole, population is projected to start declining within the next decade or so. South Asia, not too far behind. It might be a couple of decades behind, still growing. But again, by about mid-century is projected to start leveling off and declining. Sub-Saharan Africa, a very different story. Growing rapidly, a very large and young population, so there's a lot of, momentum in continued population growth, at least for another generation or two. Some projections have Sub-Saharan African population reaching 4 billion by the end of this century. Some are not so pessimistic. Remains to be seen. And then in other regions, population is already leveling off, and you have other kinds of concerns about maintaining social safety nets and so forth. On the other side here, growth in income per capita. By all means, these are not forecasts. These are projections of different scenarios, and particularly this is one of several scenarios that have been developed by the global modeling community as part of the IPCC, the Intergovernmental Panel on Climate Change process. And the goal there is not to look in depth at economic growth, but it's to take that as an input as we make projections about the impact of climate change. So we're not so interested in whether these are the correct projections of economic growth. In fact, we're pretty sure they're not correct, and obviously they don't show the impact of recent pandemic or conflict in Ukraine, for example. But they are a set of standard scenarios, some of them more optimistic, some of them more pessimistic, that the global modeling community uses in order to compare, so that we can compare across models. We're using some scenario inputs that are the same across models so that we can compare how our model's different when we look at climate change, for example, in particular. But a couple important drivers of change in the demand side. A few years ago now, Time magazine published a series of photographs, which is really interesting and illustrative. They were just, what does a family eat in a week? And so it's purely anecdotal here, but shows a really nice kind of range that also represents, I won't use the word progression, but something that tends to happen as incomes rise. So Mali, a low-income country in West Africa, you can see, basically, basic staples. A few vegetables, some cooking oil, that's what they eat in a week. Guatemala, higher levels of income, a lot more fresh produce. China, higher yet, more purchased foods, more processed foods, more meat. And in the US, again, that trend continues. So all of these are things which on the demand side change what we expect to see in the future in terms of demand for different types of food groups. Not that everyone will follow the same progression, not that everyone will end up with a diet like the US does, but certainly that as poorer income countries gain more income, demand for fruits and vegetables, demand for animal source foods are going to increase. And that, of course, has implications for resource use, it has implications for greenhouse gas emissions, it has real sensitive issues about what kinds of guidance can be provided to countries who haven't had these opportunities yet by countries who have had these opportunities already for a long time. So really interesting issues and dynamics to consider. Those are on the demand side. There are also some interesting things to consider on the supply side. Now, for much of history, increase in agricultural production came from expanding the area that was devoted, whether it was to crops or to livestock. It hasn't been true for the last half century or so. The red part of the bars here is the portion of growth in agricultural output that comes from land area, and it's relatively small, 0.5 out of 3, so a sixth or so out of growth on global average. That proportion has changed over time. The yellow bar being other inputs, increased use of fertilizer, pesticides, energy, things like that, which half a century ago accounted for most of the increase in production. That share declined over time, and today most increase in output comes from the green bar, which is total factor productivity, which basically means everything else that we're not measuring in terms of water, land, energy, fertilizer, things like that. So what is that? That's improved seed varieties from genetic improvements. It's improved management practices, better timing of application of resources, better precision geographically in applying resources. So you're not putting fertilizer on a field or even a part of a field that doesn't need it, and you're targeting it in places that do need better precision in specific application. Maybe a part of a field needs more nitrogen, another part needs more phosphorus. So all of these things come from improvements in information and also improvements in technology that allows application of those kinds of things. A bigger share of that, or that represents an increasing share of the growth in agricultural output, globally and in most countries. It's still not true in sub-Saharan Africa. Sub-Saharan Africa is several decades behind, so it looks more like the middle bar in this graph, where the larger share of growth and output is still coming from increased land area, increased use of conventional inputs. On the right-hand side here, a tremendous amount of innovation going on in all aspects of the food system, whether it's production, whether it's processing, storage, transportation, marketing, so forth. We heard a caution this morning from Ayan Kos about the implications of technology change, and often some of the most visible noise around new technology is things that don't necessarily pan out in the future. So this is not to say that all of these things are going to pan out, just that there's a tremendous amount of activity in that area. And there's certainly a historic trend that shows that innovation and productivity improvement is an incredibly important source of growth on the supply side. Another supply side driver to certainly keep in mind is that of climate change. So this graph shows on the left-hand side degrees relative to basically the Industrial Revolution, late 1800s. And the world now, in terms of global averages, is about 1 degree Celsius above the Industrial Revolution averages. Lots of uncertainty about the future. That depends on choices we make, depends on levels of emissions in the future. It also varies with the model, so there are different sources of uncertainty in these projections. And that's one of the reasons why we look at multiple projections as inputs. We have no basis for assuming one is more likely than another. We can certainly be hopeful that some are more likely to happen than others, but even the climate modelers won't put percentages on these. So we're just consumers of climate model results. We certainly don't put any kind of likelihood on any of these. But it shows the range of possible futures. Now, 4 degrees increase, is that a big increase or not? That's certainly less than the difference between the temperature here in Charlottesville last night and the temperature this afternoon. So on one hand, we're accustomed to big fluctuations. But on the other hand, when that's a global average, it does mean a lot. This graph puts climate change in a longer-term historical context, going back 20,000 years, in fact. And this is borrowed from a paper by Schell and Huber et al. In Nature Climate Change in 2016. I like the trend in temperatures. I'd like you to mostly disregard all of the yellow and orange bars on the upper left. Those are different geophysical processes that could change at different levels of global warming. Ocean circulation, ice caps melting, stuff like that. That's not my interest today. Today, my interest is in the purple and blue line that starts in the lower left and then moves up across and to the right. That's global average temperatures. What's interesting, here's where we are today after several centuries and with a turn upwards, which was that point 1850 to 1900 industrial revolution, increase in greenhouse gas emissions. So an uptick in temperatures that brings us about 1 degree Celsius up over the past century and a half. On the right, you see different projections. RCPs refer to different greenhouse gas emission scenarios, basically. Maybe a small decrease in a very optimistic scenario, or quite significant increases. What's really striking is that the entire history of agriculture, the last 10,000 years, have basically been in a period of relatively stable temperatures, within about 1 degree of where we are today. So think of all that goes along with that. That's domestication of crops and livestock, settling down, development of cities, writing, all of the innovations that basically constitute what we call civilization today has occurred in a period of relatively stable temperatures. So going beyond that 1 degree band really does have some potentially big implications. What they are, we don't know for certain, but that's precisely why it's really important to be thinking farther into the future. So this brings me to thinking about foresight and also what we can learn from hindsight. The term foresight is used in many different ways to describe lots of different approaches, so it's worth just mentioning a few of these. Horizon scanning, literally what it means, looking ahead to see what's appearing on the horizon. What can we be excited about? What should we be concerned about? Visioning, what's the future we'd like to see? What are the futures we'd like to avoid? This can involve exploring different scenarios, statistical analysis of what we know from the past, simulation modeling of different scenarios in the future. Forecasting certainly is a part of foresight. And within that, assessment of the impacts of new technologies or a change in policies. What if this happens or what if that happens? Trading off, because there are always different possible outcomes under different scenarios. There are also multiple outcomes of any given scenario, and sometimes we want to think about whether we're emphasizing a particular type of outcome or another one. Ultimately, prioritization and informing decision making. So many different approaches, many different goals from different approaches of foresight. Basically, different approaches for different purposes. They're not all designed to do the same thing. They're not all equally successful. They're not necessarily exclusive. Sometimes you'll start with horizon scanning exercise, develop scenarios, do some statistical modeling or some simulation modeling, end up informing priorities. So it could be a process that involves several of these things. Hindsight and foresight. Ideally, we want to know where we are, how we got here, before we think about where might we be in the near future or even in the more distant future. So as I mentioned before, statistical models, that's a really important part of starting with your foresight. But there are also lots of other tools, some of them more simple, some of them more complicated, some of them looking at different types of time horizons, some of them quantitative versus qualitative, all kinds of approaches, again, for different purposes. You're probably familiar with this quote, all models are wrong, but some of them are useful. These are all models. They might be mental models. They might be very explicit quantitative models. They're all, well, many of them are good for some things, definitely not good for other things. And so the degree to which they're useful depends on what we actually want to accomplish. If our goal in foresight is to understand what we collectively think is the future we'd like to reach, that certainly involves or requires participation and stakeholder engagement. If we've got lots of good data, we have really clear assumptions about what broad future patterns might look like, and therefore we're interested in a more kind of a near-term, specific, precise type of forecast, well, then a different type of approach is called for. Before I go on, anyone want to hazard a guess as to what this what this time series is on the board? This is a data set that I found on Our World in Data recently. It's pretty remarkable. It's the time series on the price of wheat in England over the past 700 years, which is the longest time series I've ever found for anything related to a food system. So there's no single measure of what a food system is or how it performs. Prices is a pretty good indicator just because it's aggregating the impact of forces on the production side and on the demand side. And this one obviously involves lots of work over many centuries. In fact, this particular graph cites, let me get the name, Maridakis and others, a book on forecasting in 1997. But they drew from a time series that had been built over centuries, obviously. Thorfold Rogers in the UK in the late 1800s gathered a lot of this data from a variety of sources, and others have updated it since then, making lots of assumptions. How do you compare prices in 1200 versus in 1900? So lots of assumptions behind that. But let's just assume this is a good data set on this particular, very specific question, price of wheat in England in pounds per ton. What can we learn from the past, this data, if we're interested in, let's say, what prices for wheat in England might look like in 2030? And I picked 2030 because that's the target date for these sustainable development goals that you've probably heard of: reducing poverty, reducing hunger, better climate action, clean water, all of these noble aspirations, which are looking, unfortunately, more and more difficult to achieve by 2030. But nevertheless, if we were thinking, what might this particular indicator look like in 2030? Well, where do we look on this graph? If you were an econometrician working for King Henry VIII in the 1500s, and you were asked to venture a guess or make a forecast about the price of wheat in the future, well, first of all, you'd be worried about losing your head. But secondly, you would be reasonable to say, well, barring a drought next year or a plague of locusts, prices have been pretty steady on average over time. 400 pounds per ton, that's the price of wheat. If you're asked the same question several centuries later, you'd reasonably have a very different answer. Things have been changing for the last 200 years. Who knows? 1,000 pounds per ton? Could be. Story changed again over the next century and a half. This series ends in 1996, but we, of course, know since then, the last couple of decades, things have turned upwards again. In fact, the price of wheat today is about $200 pounds per ton. But where will that be in 2030? Point is, we have to really understand what's going on behind a data set like this in order to draw from it, looking ahead to the future. Turns out that I mentioned Thomas Malthus a little while ago. He was writing his essay on population, published in 1798. So it was right at the end of this series of increasing prices. So it's understandable. He was concerned. He sees population rising, sees technology not changing very quickly. At the same time, I don't know that if this Malthus' essay is one of these famous things that everyone knows about, but probably nobody has ever read. I haven't read it myself. It's a book about that thick. But I know the sort of cheat sheet summary version, which is this relative rates of population versus technology growth. What he didn't account for was behavior and policy. So the other things that were going on in the 1700s were, in addition to population growth, not a lot of technology change. Landlords were enclosing cropland to shift to sheep production for wool, which was more profitable. Parliament was enacting legislation to restrict imports of cereals. So there are a lot of factors that were deliberately increasing the price of grain. That's good if you're a producer, if you're selling cereals, and not so good if you're a poor household that's buying them. And what Malthus missed was changes in behavior, changes in policy, changes in technology. Those are things that can have a big difference. And in fact, since then, globally, prices have increased pretty steadily, barring the occasional World War, barring the occasional Great Depression, but this long-term downward trend. So the question where we are now is, when we see prices tick up again, is that a glitch? Is that a shock? Or is that actually a turning point, and we're going to see something that lasts or changes direction longer into the future? And despite that uncertainty, or in fact, because of that uncertainty, that's why it's important for us to think about different future scenarios. We might not be able to make a confident prediction, but we are still interested in what would happen if they continued going up over time. So who thinks about these longer term questions? I think all of you as forecasters, you're probably accustomed to clients who have real specific interests. They're making decisions today about something based on information that the best information possible that they might know about something that's going to happen a week from now, or a month from now, or a year from now. But it's important to look beyond that as well. Farmers have to look beyond that. For the duration, the last 10,000 years of agriculture, they've had to look a season ahead, at least 3 months, 6 months into the future, when they're putting a seed in the ground. What are conditions are going to be over the next 6 months? What will the market for what I'm producing be when it's time for me to harvest this? That's something they're long used to doing. Now they have to think farther into the future. They might be thinking about whether the next generation of their own household will still be able to farm 10, 20, 30 years from now. They may be thinking about water availability, not just whether it'll rain in the next couple of months, but whether falling groundwater tables or melting glaciers or other water sources that they may rely on are going to be here in 10 years or 20 years' time. So farmers are concerned. Food companies. McDonald's sells about 6 million hamburgers around the world every day. Most of them have sesame seeds on them. Turns out most of those sesame seeds come from a few well-established supply chains that start with small-scale producers. Sesame is a labor-intensive crop. Small-scale producers in Central America. So McDonald's wondered, will these producers still be there in a generation? Will climate change wipe out our supply of sesame seeds? It may not be the most critical question in the world, but it is something that's obviously of importance to a company that makes a lot of money selling hamburgers. Turns out, well, there are risks to their particular source of supply, not so much because of climate change, at least not in the near term, but because the small-scale producers that produce sesame seeds are being drawn into other sectors of the economy. So they're likely going to have to look for other sources. The good news is there are other sources, but it will require some adjustment in their sourcing strategy. Energy companies, insurance companies, including one that started in a coffee shop in London in the 1600s. I'm going to come back to that one in a minute because it's an interesting story. Researchers, governments, most of our partners and most of our funders are government agencies, whether they're governments in developing countries who are developing their next 5-year plan and they're looking at investments in agriculture versus other sectors of the economy, and within agriculture, whether more support for maize or wheat or fruits and vegetables or the livestock sector. Or it might be government agencies in higher income countries that fund investment in research or in other international development efforts. So, Edward Lloyd. Some of you may know this story. I think it's really an interesting one, so I'll spend a minute on it. He ran a coffee house in London, and it was first mentioned in 1688. I don't know how long it had been around before then. Coffee was a new import into the UK in the 1600s. Coffee houses sprang up all over London. They tended to attract different groups of business. That tended to be places where business people sat around and talked and caught up with each other and made plans. Edward Lloyd's coffee house was on Tower Street, near the Tower of London, between that and London Bridge. And London Bridge was the highest point on the river that seagoing ships could reach. That's where they anchored. A lot of people that went to Edward Lloyd's coffee house were sea captains, ship owners, merchants. They sat and they drank coffee, they talked business, whose ship came in, what did it bring, whose ship is loading, where is it going, what kinds of conditions did they encounter. Edward Lloyd soon realized that the information that his clients were sharing was at least as valuable as the coffee that he was selling them. So he put together a newspaper, sold subscriptions, started to make money on that. He sold booths. Here's a sketch of his coffee house. He sold these booths or rented them to underwriters who found it was useful to be able to sit there and talk with ship owners and captains as they came and went to sell insurance based on this very detailed information that they were able to gather in that one source. And there's this great quote. I found this on the Lloyd's website. Not a breeze can blow in any latitude, not a storm can burst, not a fog can rise in any part of the world without recording its history here. This was their business model, collecting information, knowing better than anyone else in the world what was the probability that this ship was going to reach its destination or was going to arrive on time. And from that, being able to make better guesses. What's the risk? What's the cost or the value of that risk? And therefore make a profitable business in selling insurance. Well, that model was very successful. There we go. It still is very successful, but about a decade ago, Lloyd's, at least, maybe they'd been thinking about this before, but they commissioned a study that basically asked the question, we've had a successful model based on historical data for generations, for centuries now, but the world is changing. This thing called climate change, how is that going to affect our business in the future? Warming temperatures, changing cycles like El Nino that affect weather on shorter term cycles, changing patterns of crop pests and diseases, conflict. What if a critical trade route gets blocked, like the Suez Canal? We've seen that recently. Conflict in different places. Anyway, we contributed to a study that just looked at what if these kinds of things happen. We put no probabilities on how likely they were to happen, but if they happened, and what if they happened concurrently? What could some of the potential impacts be on prices, on production, and so forth? This is not to say that they put aside their historical data. Almost certainly they're still using it. But they're thinking about this big question about whether changes that we see now, are they a structural change or are they a shock that's going to pass? So, using foresight modeling to inform decision making. This is a very simple schematic, but it sort of summarizes the elements that go into the analysis that we do. We don't run climate models, but we're consumers of outputs from climate models. And those are run by people who look at different emission scenarios, and they calculate all kinds of complex geophysical processes that result in changes in temperature, precipitation in different parts of the world. We use those as inputs into crop models that then say, well, under different temperatures and precipitations, different levels of carbon dioxide in the atmosphere and so forth, here's what we expect different crops, how we expect them to perform. And then ultimately we use those as inputs into economic models. Some of them are general equilibrium, looking across the economy at the country level. Some of them are partial equilibrium, looking in more detail at the ag sector, at the global level, and we mix those up in various ways. Ultimately, we're interested in what do those things mean for sustainable development goals related to poverty, hunger, and the environment. We do this at IFPRI, but we do it in partnership with MIT and Oxford and other CGIAR centers and others around the world. So, one example, precipitation. The models are pretty consistent on warming associated with climate change, although they have different spatial patterns, less so on precipitation. It's just more complicated to model. That's one of the reasons why we look at scenarios from different climate models and different emission pathways to see what they could mean. On average, this is a broad, a very large generalization, but for some crops, for example maize, find that yields in the absence of any other change, just climate change, could fall by 20 to 40%. And that's a huge loss in quantity and because of the significance of that as a food crop in many parts of the world and as an input, as a feed crop in many parts of the world and also as an input into industrial processes and so forth. 20 to 40% if farmers don't respond. Of course, that's a silly assumption. Farmers are going to respond, researchers, seed companies, governments, there are all kinds of things that are going to respond, but that's an indication of the potential. The impacts vary a lot by crop and by region. On the left is maize, on the right is wheat. The yellow line is the trend under a high emission scenarios. You see that yields could fall, as I said, 30 to 40%. That's on a global average by 2100. In some areas it could be 20 to 40% even by 2050. And you see in red on the graph. Lots of tropical areas, sub-Saharan Africa, but also the Midwestern US, potentially hit quite significantly in terms of maize. Wheat is a very different story. It tends to be grown in cooler climates, so a little bit of warming, not necessarily a bad thing. It could extend the growing season. Wheat is also a different crop. I won't go into it. Some crops actually benefit from higher concentrations of carbon dioxide in the atmosphere. Wheat is one of those. Maize is not. So maize would suffer from higher temperatures and different precipitation patterns. Wheat could actually benefit. Just to say, different regions, different crops, very different impacts of climate change. Those are long-term trends. Climate change also is also projected to affect the likelihood of extreme events, whether that's drought or heat waves or whatever. Here, this just shows under different emission scenarios in the future, events that currently are severe enough to sharply reduce yields of maize in this particular case. Events that occur once in 20 years now could occur once in 5 years in many parts of southern Africa by the middle of the century. So it's not just a distant future thing, it's something that can have impacts much sooner. Just briefly, how we go about looking at this, these two top figures, temperature on the right, changes in temperature on the right, changes in precipitation. Under one particular model, this is the Hadley model of the UK, under one particular climate emission scenarios. This is a relatively rapid climate scenario. In the year 2050, those are combined. These are biophysical models that can then say, what does that mean in this case for maize using one particular crop model? All of these are choices that we can make in the modeling. All of these are examples of one scenario selection that we could compare with other scenarios. So this, again, is potential impact on yields of one particular crop, maize. Now, this is the result of a specific scientific experiment. If you're interested in the impacts of climate change, you want to change that and hold everything else constant. That's a good scientific experiment. It's not a good projection of what's going to happen in the future because we know lots of other things are going to change. We've talked about them: income, population, technology. We also need to account for the fact that if certain regions are affected in one way and others in a different way, certain crops in one way and others in a different way, there are interaction effects. There are also interactions between what producers choose to do and what consumers choose to do differently as a result of these changes in production prices. So we add in the economic dimension as well, technology assumptions, things like that. And again, this comes from a particular model, in this case the impact model, under a particular, a particular set of assumptions about socioeconomic change. So assumptions about the rate of population growth in different parts of the world, the rate of economic growth and so forth. The bottom line, I won't go into it, but the summary here is yields are actually projected to increase by 20, 30, 40% by mid-century, but they're going to increase less rapidly because of climate change. So it's just the point here that we need to look at the biophysical processes, but we also need to look at the economic interactions. I see I'm getting short on time. I'm not going to spend time on this. This just shows that the patterns vary a lot across regions, we've already noticed, and that there's this interaction between yields, production, prices, and consumption. Alongside the climate change, there are things going on in terms of response to economic growth as well. As incomes rise, people demand more fruits and vegetables, more animal-sourced foods, different degrees of change in different parts of the world. In North America, food is already a small share of our total expenditures. Patterns aren't going to change much. In South Asia, Sub-Saharan Africa, different starting points, a higher dependence originally on cereals, on basic staples, but faster growth in fruits and vegetables and animal-sourced foods. That implies different things for changes in demand. I'm going to skip over those right now. The PowerPoint I'm happy to share afterwards. On balance, we find, and we can look at this not just in terms of total production or calories, but different micronutrients as well. Between now and 2050, income change is going to be a bigger driver in our projections than climate change on the availability of different types of nutrients. That's not to say that climate is not going to become a more severe threat. These particular projections also leave out the extreme events and the variability. These are looking at the impacts of long-term changes. Combined impacts on hunger, but when you look at income and the climate and other drivers, we find the blue bar shows level of hunger in the world around 800 million in 2010. In the absence of climate change, our projections indicate that that number would have been cut by about half. That's the orange bar. Climate change reverses, doesn't completely offset that, but it sets it back by about 100 million people. That's before looking at pandemic or conflict. The good news, the orange bar then, is with increased investment in research, in resources, in access to markets. That effect of climate change can be offset, at least for this particular horizon, time horizon, under these scenario assumptions. Quick point on trade-offs. On the left are different types of investment research that affect different parts of the food system. Research to improve production, water and soil, protecting and improving the quality of the resources that go into production. Roads is shorthand for investments that improve access to markets, whether it's by producers or consumers. There are trade-offs involved. The roads is a good one. Improving access to markets, that's a good thing. It means that there's more efficiency in the system, a smaller margin between what producers can sell for and what consumers can buy for. On the other hand, that triggers, and that's an incentive for increased production, which has trade-offs in terms of increased greenhouse gas emissions and increased deforestation in this case. That's an argument for the bottom scenario here, which combines investments in the different areas. There's also a trade-off there, though, because that's the most expensive one. Not surprisingly, always a trade-off. So in our modeling, we don't end up with priorities ourselves. We say, here are possible outcomes of different scenarios, and then we work with our partners. They're the ones who put weights on the different outcomes, which ones are more important to them. And ultimately, again, I don't have time to go into this. Depending on your goal, if you're interested in reducing hunger, investing in cereals. That's the cheapest source of staple food calories. If you're interested in increasing incomes, put a little more emphasis on fruits and vegetables because that's a really high return proposition. Livestock plays a role in greenhouse gas emissions. So pay attention to livestock if that's one of your principal goals. I'm going to skip this one. Shorter term analysis of changes in prices for food, fuel, and so forth as a result of the conflict. My final couple of slides. Foresight, as we see it, has to be a process. Because it's complicated, because there are multiple trade-offs and so forth, it might start with, and this brings together different elements of a foresight approach, thinking about what the concerns are, the questions, talking to people who will be affected, asking what is it they're looking for, what do they want to avoid. Then you bring in the tools, statistical analysis or simulation modeling. The one thing that we discover that always triggers more questions. So that's why the process needs to go around and around. Can't go around forever. Ultimately, decisions have to be made. Priorities are set. We don't set the priorities. That comes from whatever decision-making process in place. It might be a larger group. It might be one person ultimately who has to make a choice. Their priorities are certainly influenced not just by the analytical results, but by many other factors, political among them. They make a choice. You look at the implications. That generates new questions, and the process continues. So, finally, I lead an initiative on foresight that brings together our partners across the different international ag research centers as well as various universities. We look globally, but we focus on developing countries and particularly on Eastern, Southern Africa and South Asia for the moment. Looking at in-depth analyses, but also shorter briefs that are more like horizon scanning. What do we know about particular topics or regions and what the future might bring for their food systems? So I invite you to check that out. Happy to talk further. And I think I've gone a little bit over, but hopefully there's still a little time for some questions. Thanks very much.
Thanks a lot, Keith. So indeed, we have a bit of time for questions, if any. Do not hesitate to raise your hand. You are too far.
Mm-hmm. Well, I'm reminded first and grateful to Ian this morning for recalling this quote from Clive Granger, I think it was. One of the benefits of long-term projections is that it'll be a long time before you actually have to confront the results and see whether they're valid. Jokes aside, Yes, that takes the shape of the questions evolving that we work with for particular partners. Some of the questions are very long-standing. We work with the U.S. Agency for International Development because they invest in agricultural research. They've wanted to know for years better information on what are the relative advantages of investing more in one region versus another, or one food group for another. So those questions, they may evolve in terms of the nuances over time, but the basic question is there. Others, what are the impacts of the conflict in Ukraine? Those come up quickly. And some of our models are better suited to responding fairly quickly, and some of them not. But that was one example where the analysis changed direction quite quickly. Not all of our analysis, but some of it was applied very quickly to look at that. In terms of validating, again, we don't do it as systematically as we should. We do know, for example, that in some cases, maize is one example where our projections, if we look back, and I wasn't there 20 years ago, but my colleagues were, if we look at projections made then, those were off because at that time we missed the big policy push that was put into biofuels, for example, in the US and elsewhere. We didn't anticipate that, and therefore our projections were quite off. Wheat turned out to be, that's more of a predictable, staple food crop, and so we did a better job of that. So it varies.
So thanks for the talk. You talked a lot about taking the climate models as inputs, but we know that the food system is also producing carbon dioxide, therefore that there's going to be a feedback loop there, I can imagine. Now, does that feature in your modeling in any way? I mean, if you see that you're forecasting a scenario for the food system, and you're taking as the input maybe a low temperature rise scenario, but the changes to the food system you see are actually going to cause a lot of CO2 to go into the atmosphere. Does that feature in your thinking in any way?
Not as well as it should. So our circle isn't completely closed there because we take the climate inputs from the climate modelers, and therefore we'll start with a scenario that they have devised and run. It means we have to be careful about which sorts of socioeconomic scenarios we match with that, and it wouldn't make sense to combine a low emission scenario with a scenario where everyone's consumption of red meat was going to double, for example. Ideally, I don't know if we'll be able to link it back other than to be careful about the assumptions that we make so that they're internally consistent. But that's a good one to be cautious about. Yeah.
So, Kit, there is this big discussion about food insecurity, which you know very well. How important climate change in terms of triggering food insecurity nowadays? And should we expect even more these types of problems in the future because of climate change? Can you substantiate a little bit? You basically skipped that section quickly.
Yeah. Climate change and food insecurity, a really important link. I showed a graph where I focused on the global figures of food insecurity or hunger. I mean, it's essentially the same definition that the FAO and other UN organizations use for food insecurity in terms of calories. And globally, the climate signal sets the number of hungry back by about 100 million. It's very different across different regions, and we didn't spend time on sub-Saharan Africa, but in sub-Saharan Africa, it essentially wipes out all of the projected gains. And that's the long-term sort of trend change in climate. It doesn't account for extreme events. So almost certainly that'll be even a bigger issue in some parts of the world. It depends on the parts of the world in terms of the climate impact, but even at least as much, perhaps more so, it depends on their level of development and what sort of infrastructure, physical infrastructure as well as social infrastructure they have to protect against things like that. But it's a big issue for sure. Yeah.
Okay, so we have a very last question here.
Thank you for your presentation. In one of your slides, you showed that a chain of outputs of forecasting models being used as inputs into other models that then get fed into your own models. And we know that forecasts, there's always a range of outcomes and errors associated with those models. And I was wondering, as we kind of look at the chain of uncertainty from each of the models feeding into your own model, how does that actually impact the outcomes of what you're modeling?
Yeah. Poorly. The models we use are deterministic. So there is a lot of uncertainty because the inputs are not known. You know, we take them from climate models and from crop models. And then even on the socioeconomic side within the economic models, the population projections, that's another set of models. The economic projections, that's another set of models. But ultimately, there are a set of specific assumptions that end up in a set of specific projection results. So we know that there's a lot of uncertainty around that. We're open about that. We don't know enough to say what's the confidence interval around that. We get around that by running lots of different scenarios. The models aren't quick enough. I mean, depending on which parts of the model are switched off and on, it can run in a minute or it might take 30 minutes to run. But it's not easy for us just to run thousands and thousands of them. Some of those results, the ones on extreme events in Southern Africa, those actually have something like 11,000 climate runs in them. So it represents a distribution, but it's still, since the climate modelers don't put probabilities on those, we don't even know what probability to translate through. All we can do is qualify the results to say, this is an estimate based on a whole series of conditions. And if we put in different assumptions, this is the range of things that we tend to find. That's, you know, there was some box and whisker plots on one of those slides. Those weren't strictly uncertainties. Those were just ranges of outcomes under different sets of assumptions. But it gives a sense of whether things tend to cluster or not. So it's a proximate answer, but it's an issue to be concerned about.
Okay, thanks a lot. So now that we have to start parallel sessions in 10 minutes, so we have to close the session. So thanks a lot, Kees, for this insightful keynote speech. Thanks a lot, really.
Thank you. Good, thank you.
Boy, that was really interesting.
Time moves right along, doesn't it?